Good morning, dear students, to the second session of the day. And for that, we have our faculty, CA Divya Prabhu, madam. Before I hand over the session to ma'am, let me introduce ma'am to you. Divya Prabhu completed her schooling and PU in Bhuvanendra College, Karkala. In the second PUC Commerce stream, she bagged first rank in Udupi district and sixth rank in the state. Completed BCom under Mangalore University from Besant Evening College. Completed her chartered accountancy in the year 2021 and had been a student of Trisha at all three levels of professional courses of CA. Madam has worked in Ernst & Young for 2 years in the indirect taxes department. Currently, Madam is taking up classes for professional courses such as CA and CS. We are very glad to have you, ma'am. Welcome and over to you, ma'am.
Thank you, ma'am, for your generous introduction. So I think we can begin with the classes, but yeah, so we can begin with the classes. But before that, I want to know if the students have joined in, and I want to know how many students have come so far. So please ping in the live chat if you are here. Good morning, everyone. Say hi and write your names. Okay, so I think, am I audible? So you can ping yes if I'm audible and just please write your names. Say hi. Okay, I can see one name, Sahana. Yes, good morning. Anybody else who has joined in? Okay, I can see some names. Yes. Sahana, Kritika, Disha, Sushmita. Yes. Okay, good morning, everyone. So we'll just wait for 2 minutes for more participants to come in and then we can begin. So is the screen visible to all of you? Can you let me know? Can you see the chart? Students, can you see the chart here? Yes, okay, fantastic. Okay, so you need not, I think some of you have this chart already, those who have attended my crash course, and those who have not need not worry because anyway, I'm displaying this chart right here. So only thing you need to have is one calculator handy and second, just your rough note, okay? So as you all know, this is a marathon revision. So which is why we won't be covering up in detail given the time constraint of 7 hours for the subject. However, important concepts, basically I'll brush you through all the concepts of stats. Along with that, whatever I feel are, not difficult questions, I wouldn't say it's difficult. The standard questions or, important questions will solve here. Just so you know, you get the practice. Okay, and guys, I've mentioned this earlier also. Please have a backup calculator even in the class here, as well as you need to carry a backup calculator for the exam as well. Do not risk your attempt due to the failure of calci. Okay, that's the last thing we would want. So shall we begin? Now, as you all know, this statistics subject starts with the theory chapter, which is statistical description of data, right? But this is one of the important chapters, and which is why you all being students of Trisha will never take a chance of skipping this chapter, even though this is a theory chapter. All right. But however, this is a theory chapter, and which is why we will be covering this chapter towards the end. So now we will move to one of the most important chapters, which has a very good weightage, which is measures of central tendency and dispersion. Okay. So first what we will do is, the approach we'll follow here is, we will quickly revise all the important formulas, because as you all know, statistics is all about remembering the formulas, okay, which is important. So anyway, this chart will be circulated to you all. And I hope that you all have already started your preparations. The preparations are going in full swing because the exams are nearing, right? So how many days left? It's 19 today, 31st is your exam, right? So hardly 2 weeks. So in this 2 weeks, I want everyone to revise these formulas every single day, because you can risk anything, but don't risk not remembering the formulas, right? So that's very, very important in statistics. Unless and until you don't recall the formulas, you cannot solve the questions. And that's why we have this chart handy. All you need to do is recall the formulas, which is why revise every single day. Okay. So let's begin with the chapter measures of central tendency and dispersion. Now, before we begin with the formulas, first thing I've told us earlier, what do you mean by this central tendency? Why? Everyone, if I ask you what is a measure of central tendency, you will tell, ma'am, it is mean, median, mode, dramatic mean, harmonic mean, which is okay. But before that, I want you to understand what you mean by this central tendency. Now, central tendency means that every set of observations will generally have a tendency to revolve or cluster around a central value. Okay, I repeat, all the observations will generally have a tendency to cluster around a central value, which is known as central tendency. Now, measuring which is that central value or the middle value is what we call as measure of central tendency. Okay. Now, this middle value we can measure using different methods, one of which is arithmetic mean, there is median, there is mode, there is geometric mean, and there is harmonic mean. Clear? So now coming to arithmetic mean, very, very simple formula we have, which is, if we have a discrete observation, the formula will be, just a second. Okay. So the formula is x bar is equal to sigma x by n, where n means number of observations. So all you need to do is add all the observations and divide by the number of observations, which is the arithmetic mean. Now, if we have grouped frequency distribution or simple frequency distribution, what is a grouped or simple frequency distribution? What do you mean by that? Basically, frequency distribution means you will have x values, you will have f, which is the respective frequencies. This is a simple frequency distribution, correct? Now, what is group frequency distribution? Instead of x, we will have, one second. Yeah. So instead of x, we will have class intervals here, right? So we'll have class intervals in case of group frequency. If we have x values, we have simple frequency. So for both these, we can use the same formula, which is summation fx divided by capital N. Now, what is this capital N? Capital N is nothing but summation of frequencies, right? So if I come here, if I multiply f into x, okay, frequency into x, what I get is summation fx. So summation fx divided by n. So what is n? N is nothing but summation of frequencies. So if I add all the frequencies, what I get is n. So summation fx by n will give me x bar, which is arithmetic mean. All these are simple formulas. I'm assuming that before attending this revision, the marathon revision, all of you have completed at least one reading, right? So assuming that this is a very simple formula with a very simple topic, so I won't go into the details. I won't even solve questions on this, okay? Because it's very simple. Now let's say that instead of x, we have class intervals, say 5 to 10, 10 to 15, and so on. In this case, do we have x values? No. So if we don't have x values, we still have to go for f into x. But where is x? Which is why we have to find x. That is the midpoint. What we find is midpoint. How do you find midpoint? 5 plus 10 divided by 2, which is lower class limit or lower class boundary plus upper class limit or upper class boundary divided by 2 will give me the midpoint. So once we have midpoint, this will be x. We will have f. F into x will be fx. Correct? This is how we calculate mean. Okay, clear everyone? Any doubts so far? Please let me know in the comment section if there is any doubts. I'll be able to solve. If no doubts, just everything is clear, just give a thumbs up. Yes, clear. Okay, we'll proceed. So this was about arithmetic mean. Now coming to the properties of arithmetic mean, this is important because MCQ, this theory-based question can be asked on the properties. First of all, summation of x minus x bar equals 0. This means that, understand this very carefully, it is the sum of deviation of the observations. Deviation means minus, okay? Deviation of the observation from its arithmetic mean will always be 0. Even if you calculate, you will get 0. But it's very important to understand this property because if they're asking you as a theory question, straight away you can answer that. I repeat, sum of deviation of observation from their arithmetic mean will always be 0. Okay, this is the first property. Next, this property is derived from what property? That is, arithmetic mean is affected by both change of origin and change of scale. Okay, because it is affected by both change of origin and change of scale, we can use this property. Now, y is equal to a plus bx. If there is a relation called y equals a plus bx, in this relation, in the place of y, we can calculate arithmetic mean of y. In the place of x, we can go for arithmetic mean of x. Understanding? So this property will apply only because it is impacted by both change of origin and change of scale. Now, let's forget about all this. So y equals a plus bx. In this, can you all tell me which is change of origin, which is change of scale? Very, very important because in this chapter of central tendency as well as dispersion, okay, in both these units, this will be very, very helpful. So I want you all to tell me y equals a plus bx, which is change of origin, which is change of scale. Which is change of origin, which is change of scale. I'll wait for the answers. Quick, quick. Y equals a plus bx. In this, which is change of origin, which is change of scale. No answers yet. Okay, I got one answer. Yes. A is change of origin and B is change of scale. Absolutely right. Very good. So A is change of origin here and B is change of scale. Reason being, the change of origin is either plus or minus. Okay. And change of scale is either multiplication or division. Always remember this one point. Now, which are the variables here? X and Y. Correct? So with the variable, we have to check what operation is happening. Now, for example, the variable is x here. Correct? Now, with x, b is getting what? Multiplied. Correct? So, what is the operation involved here? Multiplication. Multiplication is nothing but change of scale. Okay? So, always remember, you need to check with the variable what operation is happening. So, with the variable x here, B is getting multiplied, and that's why multiplication is change of origin. Then you add it to A. So A is involved in addition, which is change of origin. Very, very, very important for you to understand which is change of origin and which is change of scale. Okay. Now that you know it is change of origin and change of scale, in the place of y, we can substitute it with y bar, that is arithmetic mean of y, is equal to a plus b into arithmetic mean of x. That's all. Okay. In the place of x, we'll have arithmetic mean of x. In the place of y, we can substitute arithmetic mean of y. And the reason is because it is impacted by both change of origin and change of scale. I am repeating this again and again because you can see the exact difference when it comes to dispersion chapter. Okay. So let's proceed now. Okay. Clear so far? Now, before going to the common properties, we have the next one, which is combined arithmetic mean. Very, very simple. When you have two groups, you will have two different set of arithmetic mean. But now if I want to combine the arithmetic mean and find what is the combined arithmetic mean, I'll have this formula, which is n1 into x bar 1 plus n2 x bar 2 divided by n1 plus n2. Okay. So what, on this one, a simple question can be asked like, there'll be two set of students in the class. One is girls, one is boys. Now, girls group का arithmetic mean will be x bar 1. Boys group का arithmetic mean will be x bar 2. N1 and N2 will be given. All you have to calculate is the combined arithmetic mean. That's all, using this formula. Okay. So, we'll solve one question on this. So, you can see question number 11. I want everyone to try this question number 11. The average salary of a group of unskilled workers, say I am taking the group of unskilled workers as x bar 1, okay, which is 10,000. Then that of a group of skilled workers is 15,000. Okay, I'll take this as x bar 2, which is 15,000. If the combined salary is 12,000, what is this? It is combined arithmetic mean, which is 12,000. Then what is the percentage of skilled workers? What are they asking? N1 or N2? Understand very clearly, X bar 2 is for skilled workers and that is what they are asking. So what do we have to find out? What is N2? Okay, I'll give you 3 minutes time. Start solving. So x bar 1 is given, which is 10,000. X bar 2 is given, which is 15,000. Combined arithmetic mean is also given, which is 12,000. What is the percentage of skilled workers? Which is N2 is what? Okay, I want everyone to try, get the answer. Keep trying. I'll give you another minute. I'll just be back. Okay, I got 2 answers. Don't read the answers and just tell. It's only going to benefit you because exams are nearing. So you decide if you want to cheat on yourself or not. Okay. I'm getting the right answers. Kirtan, Adil, Nayana, Lavanya, Sahana, Mahidhara, so far, all have given the right answers, which is 40%. Others, yes, Madhav Kamath, 40. Is everyone able to get the answer? 40%. See, once you get answer, you can quickly verify. 40 is for unskilled workers. Sorry, 40 is for skilled workers, correct? So 40 into skilled workers, which is 15,000. So if skilled is 40%, unskilled will be 60%. So unskilled will be, N1 will be 60%. So multiply 60 into 10,000 plus 40 into 15,000 divided by 100. You will get 12,000 as the answer. This is how you can verify once you get the answer. Right? Okay. I hope everyone has got the right answer. So we'll proceed to the next topic. Next, coming to median. So first of all, what is median? Median is nothing but the middlemost value of the observations. Okay. Now this middlemost value we can calculate 2 ways. First of all, when the number of observation is odd, the middlemost value we can calculate using the formula n plus 1 divided by tooth value. If n is even, the number of observations is even, you can go for n by tooth value plus n by 2 plus 1 value. Okay, we'll take an example. You can see the median first case, first example, 2, 5, 10, 18 and 20. The number of observation is odd. Whenever the number of observation is odd, you go for n plus 1 by 2. In this case, the middlemost value, which is 10, is the median, correct? Now, if the number of observation is even, it is even number of observations. You can see here 2, 5, 10, 18, 20 and 25. It is number of observation is 6, correct? Which is even number of observations. In that case, you always go for the average of the middle two values. Which are the two middle values? 10 and 18. So it is average of 10 and 18. 10 plus 18 divided by 2. Understood? Such questions can be asked as theory question in the MCQ. Be very careful. So this is for discrete observations, how we calculate median. Now coming to next. If we have frequency distribution, group frequency distribution also, in that case, how do we calculate median? We have a formula which is L plus n by 2 minus cumulative frequency divided by F. Sorry, 1 second. Divided by F into C. So in this formula, what is L? L is the lower class boundary of the median class. Always remember, it's not lower class limit. It is lower class boundary of the median class. Then we have n by 2 minus cumulative frequency of the median class divided by frequency of the median class into C. What is C? C is the size of the class interval. Now, what is the formula for C? How do you calculate the size of the class interval? Can anyone tell me? How do we calculate the size or width or length of the class interval? What is the formula? Quick, quick, quick. Very important question. What is the size? Which is very easy, right? You have been studying this since your PU. What is the size or width or length of a class interval? How do we calculate this C? Waiting for the answers fast. Very, very simple question. What is C? How do we calculate? C is nothing but the size of the class interval, the width of the class interval, the length of the class interval. How do we calculate this? Upper limit minus lower limit, upper class boundary minus lower class boundary. What is the right answer? It's a very simple question and yet I have difference of opinion here. Upper limit minus lower limit, upper class boundary minus lower class boundary. Guys, if you are my students, always remember, you should never get this answer wrong, okay? Because size or class or basically the length of the class interval or width of the class interval, the formula will always be UCB minus LCB, which is upper class boundary minus lower class boundary. Please don't make the mistake of writing upper class limit minus lower class limit. It is not the right answer in every circumstance because sometimes the upper class limit will be different from the upper class boundary. That time your answer will go wrong, correct? And that is why always remember the formula for size or length or width of a class interval is upper class boundary minus lower class boundary. Nobody will make this mistake in the exam. Okay. So this is the formula to calculate the C, which is size of the class interval. Okay. I'm assuming this is also a very simple problem on this, how to calculate median. What is the first step? First step is whenever a class interval, let's say there is class interval given, there is frequency given. The first step here you calculate is CF, which is cumulative frequency. Okay. Once you calculate the cumulative frequency, the next step is you calculate what is n by 2. Now this value of n by 2, you have to check in the cumulative frequency, where is it falling. Now that class will be called as median class, right? So this is how you calculate the median of a group frequency as well. Now coming to the properties of median. Properties of median. See, I'm anyway, because this is a marathon revision session, I won't be able to solve every single question, but which I feel is very important, which is different, which is relevant, or which is a standard and challenging question which you all must solve here before going to the exam. I'll cover. If you have any other topic on which we have to take up the questions, please leave in the chat box. We have time towards the end. We'll cover up all those questions. Okay. Now, coming to the properties of median. Properties of median. First one is, you can see summation of absolute deviation, x minus median, will always be minimum. Understand? In mean we had only deviation, but in median we have absolute deviation. Absolute deviation means there will be modulus in that, which means even the negative sign will be converted to the positive sign by way of this modulus. Okay, so this is the absolute deviation. So what this property is telling is that when you take the absolute deviation from arithmetic mean, take the absolute deviation from median. If you compare the two, you can see that the median will always be minimum. Again, it's only important from the theory question point of view. Just remember that the sum of absolute deviation of observations from the median will always be minimum. Clear? Next. Again, this is also affected by both change of origin as well as change of scale, and which is why you can see here the median of y will be equal to a plus b into median of x. So in the same formula of this y equals a plus bx, here we had arithmetic mean, now we will have median. So median of y will be equal to a plus b into median of x. Understood? So this property is applicable for all of these measures of central tendency, which is a common property. Understood? Because all these are affected by both change of origin as well as change of scale. So in the place of y, you can always go for mean or median or mode of y. In the place of x, you can go for mean or median or mode of x. Clear? So this is about median. Now, because median depends upon what? The location, correct? Which is the middle value, the central value is called as the median. Because it depends on the position or the location, it's known as positional average. Median is also known as positional average for this reason. Now, one more important point we forgot is this median. Before calculating median, you can see here, anyway, the numbers are arranged in the ascending order. But if you see a question on median, the first thing it should strike you is always arrange them in the ascending order first if it is not arranged. Okay, if the numbers are jumbled up, please first step is arrange them in the ascending order and then go for solving the median. Clear? Now coming to the next topic, which is mode. Now what is mode? What is mode? Mode is the value which has highest frequency, or in other words, I can say the observation or the value which is repeating the maximum number of times, or the most repeated value is nothing but mode. Yes? Okay. So you can see here mode is equal to the one which has highest frequency. Now we will understand by way of examples. Okay. So first we have here mode. I want everyone to give the answer for this. There's number 2, 3, 5, 8, 3, 4, 3, 9. Can you tell me what is mode in this? Quick, quick, quick. What is the mode here? Fast. What is the mode? Three. Yes, I got two answers, which is 3. Why? You can see that 3 is repeated 1, 2, 3 times. Correct? And that's why mode is 3 in the first case. Now coming to the second question. The second example. 2, 3, 2, 5, 8, 5, 9. What is the mode here? So 2, 3, 2, 5, 8, 5, 9. What is the mode? 2. Okay. 2 and 5. Can there be two modes? 2 and 5? Can there be two modes? Yes, there can be two modes, and such modal distribution is known as bimodal distribution. Basically, a distribution which will have two modes. This is known as bimodal distribution. Yes, right answer 2 and 5. Because you can see that 2 is repeated 2 times and 5 is also repeated 2 times. Now, both have the highest frequency of 2. Okay, so mode will be 2, 5. Both are modes. Very good. Next, coming to the next question. 2, 3, 3, 5, 2, 6, 11, 5 and 9. What is the mode here? What is the mode here? Can you tell me what is the mode here? 2, 3, 5. Any other answer? 2, 3, 5. Okay, Anil, Adil, any others? Any other answer? They are saying 2, 3, 5. Two comma 3, 5. You sure? Can there be three modes like this? 2, 3, 5. Try model. Yeah. So 2, 3, 5 is the right answer. You can see here that 2 is repeated 2 times, 3 is repeated 2 times, 5 is repeated 2 times. And that's why all the three values have highest frequency. So mode will be 2, 3, 5. Right answer. So where there is more, some people are saying no mode. Why there is no mode? You can see that these three numbers are repeated twice, whereas the other numbers, which is 6, 11 and 9, they are repeated only once. Correct? So because 2, 3 and 5 are repeated 2 times, which will have highest frequency. And that is why these three values are modes. Okay. So again, when there is more than one mode, we call it as multimodal. There is no trimodal. Okay. More than one mode, it is multimodal. But if you have exactly two modes, this will be bimodal. Very good, everyone who got the answer 2, 3, 5. Yes. Now coming to the next question. 2, 3, 5, 7 and 11. What is the mode here? 2, 3, 5, 7 and 11. What is the mode here? So, Madhav is telling no mode. Any other answers? Okay. No mode. No mode. Unimodal. No mode. Yes. So, you all are right. There is no mode here. Reason being, all the values have only one frequency. Basically, all these values are repeated only once. There is no highest frequency or there is no value which is repeated maximum number of times, which is why it is no mode. Okay, you all are right. There is no mode. Now, can you tell me in this question, what is the mode? 2, 3, 2, 3, 5, 7, 9, 9, 7 and 5. What is the mode here? Okay, what is the mode here? Adil is telling no more. Vaishnavi is telling no more. I can see 2, 3, 5, 7. All these are repeated more than once, right? Is it no more? Hmm? All these are repeated more than once, correct? All have same frequencies. It is no more. Very, very good. You all are bright students. Because you can see here, just because all are repeated more than once does not make it mode. Mode means there should be some value which will have highest frequency than others. Here you can see that 2 is repeated twice, 3 is repeated twice, 5 is repeated twice, 7 is repeated twice, 9 is also repeated twice, which means all the values have 2 as their frequencies. There is no single value where the frequency is more than the other. Here you can see that all these had frequency of 2, but 6, 11 and 9 had 1, which is why 2, 3 and 5 are modes. Whereas in this case, all have same frequency. If remember, all the observations have same frequency, it leads to no mode, which is very, very, very important to understand. Okay, it is a case of no mode. Very good. All of you have got the right answer. Yes. So this is what is mode. Now coming back, if we have, so far we saw mode, how to calculate in case of discrete observations. But let's say we have group frequency distribution, which means the one where there is class intervals. In that case, if we have to find out what is the mode, how do you calculate? Using this formula, correct? Where mode is equal to L plus F0 minus F minus 1 divided by 2F0 minus F minus 1 minus F1 into C. Here C remains the same, which is size or length or width of the class interval, which is calculated using the formula not upper class limit, upper class boundary minus lower class boundary. Same concept you can apply here. Okay. So in median we had median class. Here we have modal class. Modal class is nothing but the class interval which has highest frequency. Okay. That's where you get modal class. So this also I'm assuming you'll be able to calculate, right? It's a very simple question on mode. Now you can see the same property mentioned here as well, because all three of them, arithmetic mean, median as well as mode, all three have the same property that they are affected by both change of origin as well as change of scale, which is why straight away in this formula, in the place of y, we can have arithmetic mean of y, we can have median of y, we can have mode of y. In the place of x, we can have mean of x, we can have median of x as well as mode of x. Straight away you can substitute. In the place of x, mean, median or mode of x. In the place of y, you will get mean, median or mode of y. That's all, because it is affected by both the change of origin as well as change of scale. Clear? So this was about mode. Now, next we have something known as partition values. So what do you mean by partition values? Partition value means those values which will divide the observations into number of parts. You can see partition. Partition means dividing, correct? It's like a border partition. So it will divide the values into number of different parts. Okay, we have 4 different types of partition values. First is median. Now median is the partition value which will divide the observations into 2 equal parts. Okay, you have this. This is nothing but median. Now this central value is median, which will divide it into 2 equal parts. Correct? So median will divide into 2 equal parts. Similarly, just like that, we have quartiles. Quartiles will divide them into 4 equal parts. For example, okay, you can see here it is divided into 4 equal parts. Always remember, now you can see that there is one median, correct, which is dividing into 2 equal parts. Like that, here we have 4 equal parts, A, B, C and D. 4 equal parts, we have 3 quartiles, which is Q1, Q2 and Q3. Always remember how many parts will be there. Minus 1 will be the partition values. For example, quartiles will be 4 equal parts. Minus 1, that is 3 quartiles will be there. Similarly, median will divide into 2 equal parts. There will be only 1 median. Right? Similarly, deciles means dividing them into 10 equal parts. You will have 9 deciles. That is from D1 till D9. Understood? 10 equal parts means minus 1 will be the decile. Percentile similarly 100 equal parts, which means you will have 99 percentiles from P1 till P90. Okay, this is the partition values, can be asked as theory question for MCQ. Okay. So I hope things are clear so far. Now we will solve one question on how to calculate these partition values. So, in case of discrete observation, so what is discrete observations? Basically, the individual value. These are discrete observations. We have the formula which is n plus 1 into pth term. Now, what is this n plus 1 into pth term? How do we calculate? We'll take an example. Write down this question in your book. Always remember, anyway, in this question, I have arranged them already in the ascending order. Correct? But if the numbers are given jumbled, just like your median, quartiles also, basically any partition value, before calculating, we first have to arrange them in the ascending order. Only then proceed with the calculation. So once they are already arranged in the ascending order, we proceed with this calculation. So write down the question first. I want you to calculate Q1, D6 and P82. Okay. Q1 we will solve together and then I want you all to try D6 and P82 on your own. Just a second. So first one is Q1. Now Q1 is equal to n plus 1 into pth term. N is nothing but number of observations. How many observations we have here? If you calculate this, it is 10. Okay. So n plus 1 means 10 plus 1 into pth term. How you write this is, now we are calculating Q1. Okay. So 1 will be in the numerator divided by, this is Q, which means quartiles. Quartiles will divide into 4 equal parts. So this will be 1 by 4th term. Got it? N plus 1 into 1 by 4th term. So 11 into 1 by 4, which is 2.75th value. This is what you will get. 11 into 1 by 4. Now, how do we write this 2.75th value? First of all, what do you mean by this? You can interpret this as, this is the second value, this is the third value. Now, what they are telling is your Q1 is your 2.75th value, which means it is between your second value and third value. Between second value and third value. So, which is that value? We'll find out. So, this how do we write is second value plus what remains? 0.75 into third value minus second value. What is the second value here? 56 plus 0.75 into third value is 65 minus 56, which is equal to 65 minus 56 is 9 into 0.75 plus 56. You will get 62.75. Yes, Adil has already got the answer. Very good. 62.75 is your answer, which is Q1. Others getting the answer? Okay. Now that I have solved Q1, it's very simple. I want you to solve D6 and P82 as well. So how do we calculate D6? Again, n plus 1 means 10 plus 1 into, remember, you are calculating 6 D6, okay? So 6 will be in the numerator divided by, what is D? D is deciles. Deciles will divide the number of, divide the values into how many equal parts? 10 equal parts. So this is 6 by 10th value, which will be nothing but 11 into 6 by 10, 6.6th value. Which is equal to 6th value plus 0.6 into 7th value minus 6th value. Okay, calculate from here. Sahana has got the answer already, which is 81.2. Others? Very good, Sahana. Others, I want the answers quick. Yes, Adil, 81.2. 81.2 is the right answer. Others are getting it? Be quick, be quick. You have a 100-mark paper, you have 3 hours, which includes maths, logical reasoning, and stats. You have to bring that speed. Okay, otherwise, 3 hours is also not sufficient for you all to complete the 100 marks paper, right? Practice, practice, and practice. This makes you fast. Okay, those who completed D6, continue with P82, which is again 10 plus 1 into 82 divided by P means percentile, so 100th value, which will be 9.02th value, which is 9th value plus, remember it is not 0.2, 0.02 into 10th value minus 9th value, which will be, okay, so many have already got the answer, which is 120.20. Very good. That's the right answer, which is 120.20. Yes, Adil, Mahidara, Sahana, Madhav, Ashir, everyone has got the right answer, 120.20. Achintya has got 122. See, I think somewhere you have made the mistake. Recheck the values again. It is 0.02 and not 0.2. Maybe there you have gone wrong. It's okay to commit mistakes here, because only then you will learn to not commit the same mistake in your exam. Okay. So check your answers again. 120.20 is the right answer. I hope everyone's getting it. Okay, we'll proceed. So this is what we saw, the partition value so far. Now understand that so far we saw the partition values for discrete observation, which means for individual values. Now if we have a group frequency distribution, which means a distribution with class intervals, in that case, how do you calculate? Remember one thing, the partition values will have the exact same approach which you apply for your median. So in median, what is the first step we do? Calculate cumulative frequency. Same step is followed here also. First, calculating cumulative frequency. Second step, we go for n by 2. Here is where the difference comes. So instead of n by 2, here we will have to change it. Now, for example, you can see, let's say quartiles. In case of quartiles, I am finding, let's say Q3, right? So in case of Q3, if you understand that Q3 means part 3 divided by 4, correct? Quartiles is total 4. So 3 by 4 into n. This is where the difference will come. Instead of n by 2 in median, here. So instead of n by 2 in the median, here you will have 3 by 4 into n. Okay, which is for Q3. That is 3 by 4 into n. That's the only difference. There you calculate median class. Here you calculate Q3 class. Rest all remains the same. Cumulative frequency, frequency and C, which is your size or length of the class interval. Here, so that's all you have to remember. Where n by 2 used to come, instead of n by 2, we have the different formula, which is, let's say Q3 means 3 by 4 into n. D6 means, can you tell? 6 by 10 into n. See here, 6n by 10, which is 6 by 10 into n. Okay. If you have P73, it is 73 by 100 into n. 73 by 100 into n. That's all. That's the only step where there is a difference. So in the formula, wherever there was n by 2, substitute it with 3 by 4n, 6 by 10n or 73 by 100n. That's the only difference to calculate median and partition values in case of group frequency distribution. Clear? Easy, right? You don't have to by heart the entire formula. Anyway, you'll be by hearting the median formula. The same formula where there is n by 2, substitute it with the relevant formula. That's all. Clear? Okay, so far you completed arithmetic mean, we completed median, we completed mode, we completed partition values. The last two topic of this chapter. First is geometric mean. Now, how do you calculate geometric mean? First of all, understand that geometric mean is something we only calculate for a given set of positive observations. Now, why do you think is the reason? We can only calculate geometric mean for positive observations. Why not negative observations? I want the answer. Quick. Why is it only calculated for positive observations and not for negative observations? If there is negative observation, for example, here, instead of 4, 8 and 16, I have 4, minus 8 and 16. Can I calculate or not? Why is it only for a given set of positive observations? If you look at the definition of geometric mean, it starts from that for a given set of positive observations, geometric mean is so and so. So why? Why is it only for positive observations? Why not negative? Can I calculate for this negative or not? No. We cannot root negative observations. Very good. That is the right answer. You cannot calculate because what is the geometric mean formula? It is nth root of product of the observations. Correct? So what we do is first multiply the observation and then take the nth root. Root we can only calculate for positive observations. If there is a negative observation, we cannot find the root, which is why only for positive observations we can calculate geometric mean. Very good. This is the right answer. So now coming to the formula of geometric mean. Geometric mean is nth root of product of the observations. Okay, in other words, first you do the product of the observations to the power 1 by n, which is nothing but nth root. Okay, 1 by small n. Now, same formula, if it is a frequency distribution, along with x values, you will have frequency values. In that case, the frequencies will become their powers. That is x1 to the power f1, x2 to the power f2, and so on till xn to the power fn. Basically, x values will be the base, frequency values will be the powers. That's all. Okay. Same formula will apply here. Now, to the power 1 by n. Can you see the difference that this is small n, this is capital N. Capital N is nothing but summation of frequencies. Wherever there is frequencies, instead of small n, we will always have capital N. That is summation of frequencies. Okay. So now coming to the properties of geometric mean. Now properties of geometric mean says that if z equals x into y, then geometric mean of z will be equal to geometric mean of x into geometric mean of y. Because you can see the variables, sorry, the variables are multiplied. So their geometric means can also be multiplied to get the geometric mean of z. That's all. Okay. Similarly, you can see the variables have been divided, which is ratio. Then their geometric means can also be divided to get geometric mean of z. Right? So this is how, this is the property of geometric mean. Now we'll first calculate how to calculate the geometric mean. So calculate the geometric mean for the observations 4, 8, 16. How will you do this? You first multiply the observations, which is 4 into 8 into 16. Correct? To the power 1 by n. N means number of observations. We have 3 observations, which is the power 1 by 3. What is the answer? 4 into 8 into 16 is 512. 512 ka cube root is what I want. Always remember, in case of geometric mean questions, it's the safest and the best option to go from option to question. Okay. Now, for example, those who know the tables, it's easier. But those who don't, in that case, see, here you know that you have to calculate the cube root of 512, which means go from the options, take cube of the option. For example, let's say the option is 10, option B 8, option C 6, option D 4. Okay. Now, instead of finding cube root of 512, I will do cube. What is 10 cube? 10 into 10 into 10 is 1000. What is 8 cube? 8 into 8 into 8 is 512. Correct? This is the answer. So always remember, in case of geometric mean question, safest way is to go from options to question. Okay, that is best. Similarly, calculate for, sorry, before going this, yeah. 4 into 20 into 36 to the power 1 by 3. Calculate for this, the geometric mean of 4, 20, 6. Four, 20, 36. See, there are two different types of questions which can be expected out of geometric mean. Okay, this is one type of question. I'll tell you what type of question is that. Before that, I want you all to try once. Then we can solve together. Okay, so if you notice that this question has multiples of the same number. Okay, which means you can write this as, now 4 into 20 into 36. I can rewrite as 4 will remain as it is. You can see that 20 is also a multiple of 4. That is 4 5s are 20. Correct? 36 is also a multiple of 4, which is 4 9s are 36. Right? To the power 1 by 3. So this is a question where the observations are multiples of the same number. This is the different type of question. In that case, this is the approach you can follow. Now 4 into 4 into 4 is what? 4 cube. Correct? So 4 cube into what remains is 5 into 9, which is 45 whole to the power 1 by 3. So this 3 and this 3 will get cancelled. What remains is 4 and cube root of 45. Understanding? This is the answer, which is 4 into cube root of 45. So this is how you solve. Always remember, this is your MCQ based question. So don't straight away go on solving as if you know everything. First, look at the options. See in what form the options are. That's when you will get an idea where to stop, which step to stop. Okay. Always remember this. Read the entire question once. Read the options once. After that, you have to check which step you have to stop. or whether you have to continue further or not. Clear? So in this case, 4 cube root 45. This is how you write the answer. Got it? So this is one type of question where the question comes in the form of multiples of the same number. Okay. So this is another type of question. Can you tell what this is? What is the hint here? You can see that all the numbers are the powers of some same number. For example, 2 I can write as 2 power 1, 4 I can write as 2 power 2, 8 I can write as 2 power 3, 16 I can write as 2 power 4, 32 I can write as 2 power 5, and 64 can be written as 2 power 6. So all the numbers are powers of the same number. You can see here, I've just increased the powers and I got the numbers. Okay, this is another type of question. So when questions on geometric mean comes, always check whether it is multiples, whether it is powers, or what type of question they are asking. Very, very easily you can solve. Now, you can see that all have the same base. When the base is same, I can straight away add the powers. So 2 power 1 plus 2 plus 3 plus 4 plus 5 plus 6. Sorry, whole to the power. How many observations? 1, 2, 3, 4, 5, 6. The power 1 by 6, which is here also to the power 1 by 6, which is nothing but 2 power. If I add all this, I will get 21 whole to the power 1 by 6. Okay, which is nothing but 2 power 21 by 6. If I simplify, 3 2s are 6, 3 7s are 21. So 2 power 7 by 2. 2 power 7 by 2. Now I can simplify this further. See, if the option comes in the form of this, stop your answer here. But look at the options. If it is further solved and put it in the form of improper fraction, then you also have to convert this. How do you convert this 2 power 7 by 2 into fractions? Okay, that's improper fraction. In this case, understand, can I write this as 2 cube into 2 power 1 by 2? Okay, so I will do the reverse calculation. 2 cube into 2 power 1 by 2 have same base, which means I can add the powers. That is 2 power 3 plus 1 by 2. 3 plus 1 by 2 is nothing but 3 2s are 6. 6 plus 1, 7, which is nothing but 2 power 7 by 2. Correct? This is the answer. So in this case, the reason I did is because I can easily get what is 2 power 3, which is 8 into root 2. This square root of, that's all is the answer. This I can easily calculate, which will be 11.31. Okay, like I told you earlier, look at the options. Sometimes option will be in this form, sometimes option will be in this form, sometimes option will be in this form. Accordingly, you have to proceed with your calculations. Always remember this. Don't be in a hurry and calculate till here, because sometimes if the option is this, simply you are wasting your time. Understood? So this is how you calculate. So you can see that geometric mean can have different types of questions. One which is a simple question. One, the question wherein the observations will be multiples of the same number. These are multiples of the same number. Another type where the numbers are powers of the same number. You can see they are powers of the same number. This is another type of question. Very important. Geometric mean questions are interesting. So now that you understood, okay, multiples, powers of the same number, etc., I will give you one more question which you have to solve. Can you all try this? 2, 4, 8 till 2 power n. See, this is a clue that the numbers which have come here are 2 power something, correct? So what is this? Nothing but 2 power 1, 2 power 2, 2 power 3 till 2 power n. Okay, I want you all to calculate this and get me the answer. Fast, fast. If you want, I'll give you the options. I want everyone to try because I've explained very, very clearly what different types of questions can come on geometric mean. So this is the question, calculate geometric mean. I've given you options also. Find which is the correct option. See, whenever this hint is given, understand it is 2 power something. So what do? First multiply the observations to the power 1 by n. So 2 power 1 into 2 power 2 into 2 power 3 till 2 power n whole to the power 1 by n. Can you do it further? From here, can you calculate? Okay, I've got one answer. Mahidhara is telling it is option C. Others? We'll see who is getting the right answer. Quick, quick. Only one answer so far. Okay, Tanisha also said it is C. What about others? Stuck anywhere? Sahana is telling none of the above is the answer. Kritika is saying C. Okay, I'll solve here. You can find out if your answer is right or not. So see, when the powers, when the base is same, you can always add the power straight away. So 2 power 1 plus 2 plus 3 till n to the power 1 by n. Now what is this? What is this? It is the sum of first n natural numbers. And the formula for that is n into n plus 1 by 2 whole to the power 1 by n. Now this n and this n gets, so what remains is 2 power n plus 1 divided by 2. That is option C is the right answer. Very good. Those who have got option C as the answer, very good. This is the right answer. Others, see, I told you this is the hint that the numbers are 2 power something. All you had to remember was this. Interpret this as the sum of first and natural numbers and remember the formula. I think majority of you even forgot what this formula is, right? Okay, so this is one of the good questions on geometric mean. Okay, I'll just give you one more minute. Those who have not copied, copy this and then we'll proceed with harmonic mean, the last topic of the first chapter. Okay, now coming to the last topic here, which is harmonic mean. See, harmonic mean is basically the inverse or ulta of arithmetic mean. You can see here it is summation of x by n. So here we will have n divided by summation of 1 by x. So all the values you first do reverse. Okay, that is inverse of the values. Add them, which is divided by n. Okay, n divided by summation of 1 by x. If we have frequency, I told you in the place of n, it will always be capital N, which is summation of frequencies. Here, all the difference is that it will be, instead of 1 by x, you will have f by x. That's all. Summation of f by x. This is how you calculate harmonic mean in case of frequencies. Next, just like your combined arithmetic mean, you have combined harmonic mean here. If you see, arithmetic mean, we multiply n1 into x bar 1, whereas here we divide N1 by H1. It is ulta, I told you, correct? So it is N1 plus N2 divided by N1 by H1 plus N2 by H2. This is how we calculate combined harmonic mean. Simple questions will come on this. Next, the last here topic is, what is the relation between our harmonic mean, arithmetic mean and geometric mean? See, set of positive numbers in general, arithmetic mean is greater than or equal to geometric mean, greater than or equal to harmonic mean. Okay. But let me tell you one difference. You can see here question 14. Which of the following results hold for a set of distinct positive observations? Always remember, if the numbers are same, that is 2, 2, 2, same numbers, that is same set of observations, same numbers are there, the relation will be AM is equal to GM is equal to HM. Now, if the numbers are different, say there is 2, 3, 5, 8, 11, so on. AM will be greater than GM, will be greater than HM. Okay. So if the numbers are same, this is the relation. If the numbers are different, this is the relation. But in general, if nothing is mentioned in the question about what the numbers are, whether they are same numbers or different numbers, we go for AM greater than or equal to GM, greater than or equal to HM. And that is why in this chart you can see in general it is AM greater than or equal to GM, greater than or equal to HM. Okay. But coming to this question, can you tell me what is the answer for this? Which of the following holds for distinct positive observation? Again, they mention positive because unless it is positive observation, you can't calculate geometric mean. That's the reason. Now, for distinct positive observations, can you tell me what is the answer? Distinct positive observations, what is the answer? Madhav is telling A. Others, what is the answer? Quickly. Distinct positive observations. See, understand very clearly. I just explained to you. What do you mean by distinct? Which means different. So if the observations are different, they are distinct, which means that relation will be AM greater than GM greater than HM. So option C is the answer, not option A. If it's not mentioned distinct, it's just mentioned for a set of positive observations. In that case, it will be AM greater than or equal to GM greater than or equal to HM. Got it? Got the difference? Understood. So if it is just a positive observation in general, then option A is the answer. But if it is distinct positive, which means the observations are different, then this is the answer, which is option C. Got it? Understood, everyone? Don't make this mistake in the exam. Right? Now, when there are two observations only, in the question you can see there are only two observations. We have a separate formula, which is AM into HM will be equal to G square. So using this formula, you can find any one of these, which is AM or HM or GM, okay? Which is nothing but AH equals G square. That's all. Clear? Now coming to the last point here. Weighted average. Why do you go for weighted? Why not just arithmetic mean? The reason is sometimes the observations will be of equal importance. Because of that, we have to go for weights, which is weighted arithmetic mean. The formula is summation Wx by summation W. Okay. Same thing. The weighted geometric mean, you can see that the formula is exactly like your geometric mean. Wherever there is frequency, just substitute that with weights. Rest all is the same. In the place of frequencies, you will have weights. That's all. Clear? Now, there is one common property for all of this, that if all the observations are constant, then mean, median, mode, geometric mean, harmonic mean also will be constant. You can try 2, 2, 2. What is arithmetic mean? What is median? What is mode? Everything you can try, but you will get the same answer. So if all observations are constant, which means the same, then all of this will also be constant, which is the property which is common for all these measures of central tendency. Clear? Hope you understood this chapter now. We have arithmetic mean, we discussed median, mode, geometric mean, different types of questions under geometric mean, harmonic mean as well. Okay, so here we complete, but before that, some of the important questions which I feel are relevant to discuss with you from the material we'll discuss quickly. We'll take 2 minutes break and then go for the next chapter. So, while computing the arithmetic mean from a grouped frequency distribution, we assume that, understand, all the values of a class are equal to the mid value of that class. Why? What they are trying to tell is, grouped frequency distribution means one with class interval. In that case, we always go for midpoint, correct? That's why all the values are equal to mid value of that class, which is equal to the midpoint. So this is what they trying to tell. Got it? Can we proceed? Yes. Which of the following statements is true? Just remember, best measure of central tendency is always the arithmetic mean. Usually, mean is the best measure of central tendency. For open-end classification, which of the following is the best measure of central tendency? For open-end, we always use median. Always remember this. For open-end classification, we go for median. Why? What is open-end classification? There is no ends. Okay, for example, let's say greater than 5, 5 to 10 to 15, 15 to 20, 20 to 25, or more than 25. This is open end. You can see that here the ends are open. In this case, which is the best measure, you can't go for AM because for AM we want midpoint. How will you calculate midpoint of this and this? Not possible. So the best is always median, because median generally will take the central value itself. It will completely ignore the ends. Why? Because median means it is the central most or the middlemost value. It's the positional average. So always your median class will come somewhere in the center. It will never come the first or last one. Got it? And that's why for open-end classification, always remember the best measure of central tendency is median. This is the answer. Clear? Next. The presence of extreme observations does not affect arithmetic mean, median, or mode. Just now we discussed open end means last two intervals ka ends will be open. Correct? You have to assume the values there. In this case, extreme observations does not affect. For us, show you this. How does it matter whether it is 20, 2, 10, 50, anything? We are only concerned with the middle value, correct? So the end or the extreme values are not affected for median, because we always focus on the central value, the middle value. So the presence does not affect median. Clear? Now, which of the following is not uniquely defined? Not uniquely defined means, now for example, mean. How do we calculate mean? Add all the observations, divide by number of observations. How do we calculate median? That is the middlemost value. How do we calculate mode? The one which has highest frequency. It is just told it has highest frequency. Sometimes there can be one mode, there can be more than one mode, two modes, sorry, three modes, no mode, etc. Correct? Whereas median, you get one median. Mean, you get one mean, but modes can be more than one. Sometimes no mode also. So there is no unique definition for mode. Okay. So which is not uniquely defined is mode. Understood? Next. This is what we discussed sometime before. Weighted average are considered when all the observations are not of equal importance. Because they are of different equal importance, basically they have different importance. That is the reason we have to assign weights to them, which is why we go for weighted average. Okay, when one particular value is more important than the other value, we will assign different weights to them, and which is why we go for weighted average instead of average. Now I want you all to give me the answer of this one. When a firm registers both profits and losses, which one of the following measure of central tendency cannot be considered? I'll wait. Give me quickly the answer for question number 15. When a firm will have both profits as well as losses, which of the following cannot be considered? Which is that we generally don't consider. Keep the answers coming. After explaining everything. Okay. B, option B, which is geometric mean. Very, very good. This is the right answer, because if it has losses, which means we will have negative values, losses always come in negative. Again, just to repeat, negative values means you cannot calculate geometric mean, and that is the reason geometric mean is the right answer here. Very good. Which of the following measures satisfies a linear relationship between two variables? If there is a linear relationship, always remember it is denoted using y is equal to a plus x. This is the standard format of a linear equation. Okay. If there is a linear relationship, which means this holds good. Now, which of these will have y is equal to a plus bx? Answer is all of this, because I told you y is equal to a plus bx, and that is why in the place of x we can have mean of x, calculate mean of y. In the place of x we can have median of x, calculate median of y. Mode of x, calculate mode of y. All this will be satisfied. Got it? That's because all three, mean, median as well as mode, are affected both by change of origin and change of scale. This is change of origin and this is change of scale. Understood? So it is all of these. Okay, so I think we'll just solve one last question. Always remember, when you see a question like this on rates, rate means what? 500 kilometer per hour, or 50 rupees per piece. Anything, any rate question is given. In such case, you always apply harmonic mean. Okay, which average to apply is harmonic mean, because you can see they don't generally ask you straight away what calculate harmonic mean, calculate geometric mean. No, you can see the question what is asked is the average speed of the airplane. Now you know that some average you have to apply. Which average to apply, whether it is arithmetic mean, geometric mean, or harmonic mean? Understand? If the question is on rate, always go for harmonic mean. Got it? So you can see here, the question is that an aeroplane flies from A to B at the rate of 500 km per hour and comes back from B to A at the rate of 700 km per hour. Don't apply your science brain here. We do not, for us, nothing is relevant. How much is the kilometer, hour, speed, nothing. Just understand it is a question on rate. So it's a question on harmonic mean. And you can see only two numbers here, which is 500 and 700. So all you need to do is calculate harmonic mean of these two numbers. Okay. How do you calculate? What is the formula? N divided by summation of 1 by x. What are the x values? X values are 500 and 700. So how do I calculate this? 1 divided by 500 plus 1 divided by 700, which is Can you calculate? 1 by 500 plus 1 by 700. It is 2 divided by this because n divided by summation. So the answer is, okay, already Adil and Sana have got the answer, which is 583.33. Very, very good. Option B is the right answer. Just that you have to remember, question on rate, always apply harmonic mean. Second thing, just to see that what numbers are given, calculate harmonic mean of those numbers. That's all. Okay. Don't apply any logic, distance, speed, nothing is relevant for you all. Clear? So this was all about the very first and important chapter because it is very important and you can expect around 8 to 12 marks at least from this chapter, which is why I went a little detailed into this. So now we'll take a quick break of 5 minutes. Okay, it's 11:33 now. Yeah, by 11:40 we'll start the next chapter, which is dispersion. Now on dispersion, I'm not going to solve all the questions. We'll just quickly revise the concept and the formula. That's all. Okay. Meanwhile, just look at the chart, quickly revise. And if you have any doubts in this particular uh, chapter, which is central tendency, you can ask me. Sana is telling she's really enjoying the teaching method. Yeah, thank you, Sana. I'm also enjoying taking classes for you all because all of you are very, very interactive in the live chat. So this is what is making me teach you all like this. Right? That's the only way where both of us interact, and that's when you can take the maximum benefit of the class. So I expect all of you to keep answering me, interacting with me so that we can make this class very lively. All right. So I think we'll begin. So far we have discussed what is the measure of central tendency, which are the different measures of central tendency. And now, once we understand what is central tendency, the next related topic is what is dispersion. Okay. So, like I told you, all the observations have a tendency to cluster around a central value. Once you have measured which is that central value, the next concept is for you to understand from the central value, how much are the other observations scattered? This scatteredness or the deviation of observations from the middle value is known as dispersion. Like for example, let's say there is 2, 3, 5, 7 and 9. Okay. So what is the arithmetic mean of this? 2, 3, 5, 7 and 9. How do you calculate? 2 plus 3 plus 5 plus 7 plus 9 divided by 5, which is 5.2. Correct? So that is somewhere here. So from this value, how much are the other observations deviated? How much are they deviated? How much are they scattered from 5.2? So measuring that scatteredness, measuring that deviation is known as measures of dispersion. Here, so this is what we call measures of dispersion. And that is the reason measures of dispersion can never ever be negative. Remember this, if at all you get some measure of dispersion as minus, which is wrong, because how much is it deviated, how much is it scattered, you can never measure it in negative terms. And that's the reason measure of dispersion can never be negative. Now there are two types of dispersion. One is absolute measures of dispersion. One is relative measures of dispersion. Very important difference is that absolute measures will always come with the units, which means that in the answers, there will always be unit of measurement along with that. Okay. Whereas relative measures of dispersion, there will be without units, which means that in the answer of relative measure, you don't include any unit of measurement. That's the very important difference between the two. Absolute is always with units, relative is without units. Okay. And that's the reason when there is a different unit of measurement, for comparison, we always go for relative and not absolute. Relative is the one which is generally used for comparison. Got it? Now, which are the different absolute measures of dispersion? Range, quartile deviation, mean deviation, standard deviation. And for relative, we have coefficient of range, coefficient of mean deviation, coefficient of quartile deviation, and coefficient of variation. Okay, so these are the different relative measures. These are the different absolute measures. So coming to the first one, which is range. Okay. So what is range? Range means the largest observation minus smallest observation. It's the largest observation minus smallest observation is range. Always remember, because range is an absolute measure of dispersion, in the answer of range, you always include units of measurement. Very, very important to note down. Range will always be with the units. So in the answer of range, always include units of measurement, whether it is kgs, rupees, anything. Okay. Now let's say if there is a class interval given, you know that largest number we have to take minus smallest number. So in case of class interval, you go for upper class boundary of the largest number minus lower class boundary of the smallest class interval. The largest class interval ka upper class boundary you take, smallest class interval ka lower class boundary you take. This is how you calculate range. Now for comparison, like I told you, we go for relative measures, and coefficient of range is relative measure of dispersion, and which is why in the answer of coefficient of range do not include units. So range will be with the units. Okay. Coefficient of range will be without units. Always remember this question can be asked. Okay, very important. So what is the formula for coefficient of range? It is largest minus smallest divided by largest plus smallest into 100. So what answer you get? Don't include the unit of measurement. Here. Next, there is a special formula, but this special formula we apply only when there are two observations. In the question, you can see exactly two observations, which is when you apply these formula. First one, standard deviation is equal to range divided by 2. Okay. So once you calculate range divided by 2 will be the standard deviation. Second formula will understand later. Okay, so far you understood range. Range is largest observation minus smallest observation. If it is given in the form of class interval, UCB of the largest class interval minus LCB of the smallest class interval will be range. Range will come with the units always because it is absolute measure of dispersion. Coming to coefficient of range, this is relative measure of dispersion, which is calculated using L minus S divided by L plus S into 100. So in the answer, do not include units. Okay. Next, coming to the second, will come to mean deviation. One second. Before this, we'll solve one question on range. So coming to the properties of range, which is common for all the measures of dispersion, that the range is affected only due to the change of scale, which means it is not affected due to change of origin. You can see here, this is a common property for all of them. You can see here, is a common property for range, mean deviation, standard deviation, quartile deviation. All the four measures of dispersion have a common property that it is not affected due to change of origin, which means it is only affected due to change of scale, which later we have clarified that only affected due to change of scale, and that also value only. Sign you have to ignore. Okay. So range is affected only due to change of scale, in that also value only. So let's solve one question quickly on this. Say there is a relation between x and y, which is 2x plus 3y is equal to 10. Range of x is given as 15. Calculate what is range of y. Okay. Try this. First of all, understand whenever a question on range comes based on the property of change of origin, change of scale, always remember you have to calculate now what? Range of y. So always keep y in the left hand side. So in this relation of 2x plus 3y is equal to 10, I will keep y in the left hand side because I want to calculate range of y. Okay. So 3y is equal to 10 minus 2x, right? Or y is equal to 10 by 3 minus 2 by 3x. Now in this equation, y is equal to 10 by 3 minus 2 by 3x. Can you tell me which is the change of origin, which is the change of scale? Quickly. Which is the change of origin, which is the change of scale? See, this method is not like how you used to calculate an arithmetic mean. You can't straight away substitute the value of x and calculate range of y. That is not possible, right? So I just want you all to tell me which is the change of origin, which is the change of scale in this particular equation. So you all are giving the answers. Okay, listen, understand carefully. I told you always remember with the variable what operation is happening, you should check. What is the variable here? X. With the variable 2 by 3 is getting multiplied. So this is what? Change of scale, and this is change of origin. Always remember, range is not affected due to change of origin, which is why you can ignore this straight away. It is only affected due to change of scale, and that also value only. So in this case, y is equal to 2 by 3x. I am ignoring this minus because I'm taking only value, correct? So y is equal to 2 by 3x. So range of y is equal to 2 by 3 into range of x. Range of x is given as 15. So 5, 3 5s are 15, 5 into 2 is 10. So many of them, I think Vivek and Suchmita have got the right answer, which is range of y will be 10. Understood? So this is how you calculate the questions on range, which is based on the property of change of origin and change of scale. So this was an arithmetic mean question. Straight away in the place of x, I could substitute the range of, the arithmetic mean of x and calculate y. But because it's a question on measure of dispersion, this is exactly the method you should follow. Same method will apply whether it is range, whether it is standard deviation, whether it is mean deviation, whether it is quartile deviation, because all four have same property that it is not affected by change of origin. It is only affected by change of scale. In that also, value only. Sign, it is not affected. Understood? So here, even though it is minus 2 by 3, I am only taking 2 by 3 because it is only affected by value and not sign. Clear, everyone? I hope you understood so far. So any question which is based on the property of range or QD or MD or SD, same method you apply. Whatever they are asking you to calculate, range of y. So keep y in the left hand side. Okay. Once you get this equation, determine which is change of origin, which is change of scale. Change of origin you ignore, only change of scale you take. So in the place of y, you write range of y. In the place of x, you write range of x. Substitute, you will get the answer. That's all. I hope things are clear so far. Any doubts, please post in the live chat. We can discuss. Okay. So assuming you have understood so far and we can proceed. So far we have understood about range. Now moving to mean deviation. Now what is this mean deviation? Mean deviation is the sum of deviation, that to absolute deviation. Absolute deviation comes when it is modulus. When there is modulus, absolute deviation, which means you are ignoring the minus sign, you are only taking the plus signs. Okay. So it is sum of absolute deviation of observations from appropriate measure of central tendency. This A stands for appropriate measure of central tendency, which can be any measure of central tendency, either mean, median, or mode. So in the place of A, I can write mean, I can write median, I can write mode. Got it? Because A stands for appropriate measure of central tendency. So any of these central tendency measures I can take. Understood? So mean deviation is equal to, it is the sum of absolute deviation of observations from the appropriate measure of central tendency, which can be mean, median, or mode. So A can be anything. Now, if there is frequency involved, this is for discrete observations. If it is frequency involved in the question, all you have to do is, once you calculate x minus a, multiply that with f. That's all. So the formula will have summation of f into x minus a divided by capital N. Capital N is summation of frequency. Again, here also A stands for mean, median, or mode. That's clear. Next, coming to coefficient of mean deviation. It is mean deviation divided by A into 100. Again, if here you have used mean, here also there will be mean. If here you have used median, here also there will be median. Whichever A you have used in mean deviation, same A will come in the coefficient of mean deviation as well. So A can be mean, median, or mode, depending upon which you have used in the mean deviation formula. Got it? So this is the mean deviation so far. Question on this is very simple. You can calculate on your own. Okay, I'm sure you have calculated many of this in the class, so it should be easy. Any doubts in solving the question, you can let me know. All right, so this was about mean deviation. There's just one property which is addition to the other common properties. If you remember, In measures of central tendency, there was one property of median, that the sum of absolute deviation of mean from median will always be minimum. So which means for mean deviation also this will be the same property, right? Correct? Now mean deviation, if I am taking from median, it will always be minimum. Mean deviation can be taken from mean, it can be taken from median, it can be taken from mode. But if I am taking it from median, the answer will always be minimum. Again, it's only important from theoretical question point of view. If at all they ask you, just remember, it's the same property for central tendency also, dispersion also. Always median as well as mean deviation from median will always be minimum. Here. Now, coming to the next concept of standard deviation. So, see, this modulus is not our mathematical property. It's not a math thing. Okay. Because we wanted to avoid this modulus, we went for standard deviation. Because in standard deviation, to convert negative values into positive values, we don't use modulus. We use square. Understood? We use square. That is summation of x minus x bar the whole square divided by n. This is the formula for SD. You can see that this question can be asked as theory question. Standard deviation is root mean square deviation, which means there is a root. Okay, this is a mean itself, because what is the formula for mean? Summation x by n. Okay, here we have summation x minus x bar whole square divided by n. So it is also a form of mean itself. So it is root mean square deviation, and where the deviations are taken from arithmetic mean. You see the difference in mean deviation. This could be anything. It can be arithmetic mean, it can be median, it can be mode. Okay, in mean deviation. But in standard deviation, we always take the deviation from arithmetic mean itself. Very, very, very important. Only when the deviations are taken from the arithmetic mean of observations, we go for standard deviation. Always remember this. Any theory question can be asked out of this definition. Okay. So deviation from specifically arithmetic mean means it is standard deviation. If it is arithmetic mean, if it is median or mode, anything that is A means appropriate measure of central tendency, it is mean deviation. Here. So this formula, we can use a shortcut formula, which is summation x square by n minus x bar whole square. Similarly, if it is frequency, we just have to multiply with f. That is summation fx square by capital N minus x bar whole square. There is something known as variance, and variance is nothing but square of standard deviation. That is, variance is denoted by sigma square. Okay, sigma is nothing but standard deviation. So variance is sigma square. Clear? Now the relative measure of this is coefficient of variance. Coefficient of variance formula is SD divided by arithmetic mean. Why arithmetic mean? Because I told you we only use deviations from arithmetic mean. That's why this will always be arithmetic mean itself. But in mean deviation, this A can be anything. Correct? It can be mean, it can be median, it can be mode. Which is why this is also A itself. But here it is always AM. Okay, which means it is sigma divided by x bar into 100. This is your coefficient of variance. Clear? Now, just like your arithmetic, combined arithmetic mean, combined harmonic mean, we can calculate combined standard deviation as well. The formula for that is n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square divided by n1 plus d2. Okay, so this is the formula. Simple question will be asked. You just have to identify what is n1, what is s1, n2, s2, d1 and d2. How do you calculate d1 and d2? D1 is equal to, you need to first calculate combined arithmetic mean minus x bar 1, that is D1. D2 is difference 2, which is combined arithmetic mean minus x bar 2. which means that to calculate the combined standard deviation, you have to first calculate combined arithmetic mean. Only then you will get D1 and D2. Generally, D1 and D2 will not be given in the question. You yourself have to calculate combined arithmetic mean first and then go for D1 and D2. Once you get D1, D2, substitute in the formula for combined standard deviation as well. Clear? So this was about standard deviation. Now, quickly one question we will solve on standard deviation. So the numbers are 53, 52, 61, 60 and 64. Calculate standard deviation and coefficient of variance. Try fast. How do you calculate standard deviation? Standard deviation of x formula is equal to root. What is the formula? Summation x square by n minus x bar whole square. Correct? Once you get standard deviation, substitute here to calculate coefficient of variance. So understand everything in the calc you have to do so that you can do it quickly. See, two things you need here. One, x bar whole square, which means first thing we have to calculate is arithmetic mean. How do you calculate? Add all the numbers divided by number of observations. Second thing you want is summation x square. How do you calculate summation x square? X square of all the numbers and then add them. Basically 53 square, add them. 52 square, add them. 61 square, add them. How will you add them in the calculation straight away? 53 square into equal to m plus. 52 square m plus. 61 square m plus. 60 square m plus. 64 square m plus. What you get is 16,930. It is summation x square. Now calculate x bar. What is x bar? 53 plus 52 plus 61 plus 60 plus 64 divided by 5, which is 58. Correct? So 58 is x bar. So my standard deviation will be summation of x square, which is 16,930 divided by n. 1, 2, 3, 4, 5. 5 minus 58 whole square. What is the answer? 16,930 divided by 5. 58 square is 3364. .69 will be your standard deviation. This will be 4.69 divided by x bar. X bar is 58 into 100, which will be 4.69 into 100 by 8. 8.08. Okay, many of you have already got the answer. Very good. It is 8.08 or 8.09. Same thing. This is your coefficient of variation. Very simple. Just that. Only thing is, please do everything in Calc very quickly. Don't sit and draw all the lines, columns, etc. This is not important because exam what you have is MCQ and not descriptive. So it does not matter what you write. Ultimately, you should get the right option. And that is why, just remember x bar, straight away calculate in the Calc. Summation x square, do x square of 53, 52, 61. Go on adding in your m plus. That is 53 square m plus, 52 square m plus, like that. Once you add everything, do MRC. You will get the answer 16,930. Okay. This is the speed you should have. Okay. So I hope everyone has got the answer for standard deviation and coefficient of variance. Now next is, we have the last topic of measures of dispersion, which is quartile deviation. Quartile deviation means very simple. It is basically two quartiles. Q3 minus Q1 divided by 2 will be your quartile deviation. Now sometimes in the question this will be given Q3, Q1 directly. The higher value will be Q3, the lower value will be Q1. But let's say they have not given, straight away some values have been given. First you have to calculate what is Q3, what is Q1, and how will you calculate this? Remember, some time back we had calculated using the formula n plus 1 into p theta, correct? So using that formula, you have to first calculate this one. Using this formula, first calculate what is Q1, what is Q3, and then go for Q3 minus Q1 divided by 2. It's very simple. This is quartile deviation. Now, if you want coefficient of quartile deviation, same formula, Q3 minus Q1 divided by Q3 plus Q1 into 100. This is coefficient of quartile. Like I told you earlier, let me repeat. Quartile deviation is what? Absolute measure of dispersion. So this will be with units. Whereas coefficient is what? Relative measure. So this will be without units. It is applicable for all the measures: range, quartile deviation, mean deviation, standard deviation. All four are absolute measures. So with the units, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variance, these are relative measures of dispersion. So it is without units. Okay. Now, if you remember, I told you for open-end classification, if it is a central tendency, the best measure is median. Just like that, if it is open-ended classification, best measure of dispersion will be quartile deviation. Because quartile deviation approaches exactly like your median. And that's why the best measure for open-ended classification is quartile deviation. Just like how median is the best measure of central tendency for open-end classification. So you have to remember, if it is an open-end classification, best measure of central tendency, best measure of dispersion. Best measure of central tendency is median. Best measure of dispersion is quartile deviation. Important question from theory point of view. You have to remember, for open-end classification, best measure of central tendency is median. Best measure of dispersion is quartile deviation, because both quartile deviation and median have the same approach. We only focus on the middle value, the positional average. Got it? The ends are irrelevant to us, or both. Yeah. So this is why this is the best measure. Now, which is the best measure of central tendency? Generally, it is arithmetic mean. Just like that, the best measure of dispersion is standard deviation. Remember this also. Best measure of central tendency is arithmetic mean, and best measure of dispersion is standard deviation. This is also important. Here, so here we almost completed dispersion as well. So two common properties. First common property says range is equal to mean deviation is equal to standard deviation is equal to quartile. Basically, all measures of dispersion are not affected due to change of origin. They're only affected due to change of scale, and that to value only. Ignore the sign. Okay. Now, if all observations are constant, range is equal to MD is equal to SD is equal to 0. How do you explain this? Let's say 2, 2, 2. Okay. If all the observations are constant, arithmetic mean will also be constant. Median will also be constant. Why? Median is the middle value. Correct? Mode will also be constant. Basically, everything will be constant. Okay, that is measure of central tendency. But when it comes to measures of dispersion, can you tell me what is range here? Range is equal to 2 minus 2, which is 0. If you calculate standard deviation, if you calculate mean deviation, all this will also have answer 0. You know what is the logic behind this? Why is it 0? This will be constant. This will be constant, but this will always be 0. Why? Because once you know that central tendency is 2, the central value is 2. Now, what is dispersion? From the central value, how much are other observations scattered? Now, central value is 2. Okay. There is 2. There is 2. All three observations are clustered around 2 itself. Nothing is scattered, which means dispersion is 0. Scatteredness is 0. Deviation is 0. And that is the reason range is equal to SD is equal to MD. All these are measures of dispersion, which will also be 0. Understanding? There are three observations, 2, 2, 2. Correct? Now, all three observations are clustered upon one another only. Nothing is dispersed, nothing is scattered, nothing is deviated. And that's why the entire measure of dispersion will be 0 itself. And that's the reason you can see if all observations are constant, say K, then range or this will always be very, very important for you to understand. Okay. So this was about measures of dispersion. So far we saw what is measure of central tendency, different measures of central tendency. And then we saw from central tendency, how much are the observations dispersed or scattered or deviated, which is nothing but dispersion or measure of dispersion. Two types of measures of dispersion. One is absolute measure, one is relative measure. Absolute measure always comes with the unit. So range, QD, MD, SD with units. Whereas relative measure comes without units, but relative measure is something we use for comparison. Okay. This is what we saw so far. The important questions we can pick up. See here. Dispersion measures. What does it measure? I told you how much are the observations scattered. It measures scatteredness of a set of observations. When it comes to comparing two or more distributions, we consider, I told you for comparing we use always relative measures of dispersion. We don't go for absolute measures. Always it is relative measures. Okay. Now, which of the measures is not affected by presence of extreme observation? Which of these are not affected by presence of extreme observations? Can you tell me which is the answer? Which measures is not affected by presence of extreme observations? In central tendency, what is that? Median, correct? In central tendency, we had median. Just like median, I told you what is that? Quartile deviation. So here, the answer is quartile deviation. Because median and quartile deviation exactly will have same concept, same approach. Got it? This we learned already. Appropriate measure of dispersion for open end is quartile deviation. Measure of central tendency for open end is median. Okay. Most commonly used measure of dispersion is standard deviation. Just like arithmetic mean is the most commonly used measure of central tendency. Got it? Next. For any two numbers of SD is always, for any two numbers, SD is always. Can you give me the answer for this? For any two numbers, standard deviation is always. We learned this using the formula. for any two numbers, SD is always, we saw the formula, right? What is the SD formula? Range by 2. So it will be, SD will be half of the range. Very good, Vivek. Answer is B, which is half of the range. Range by 2 is the formula. Question 20 and 21, I want everyone to get this right. Understand this carefully. If all observations are increased by 10, then SG would be increased by 10, mean deviation would be increased by 10, QD would be increased by 10. All these three remain unchanged. Question number 20. I want everyone to answer it correctly. If all the observations are increased by 10, then what is the answer? Understand? All the observations are increased by 10. Plus 10 I am doing. What is the answer? Sahana says option D. Anybody else? Mukambika says option D. What about others? Understood the question? All the observations I am increasing by 10. See, increasing by 10 means what? Plus. Plus is nothing but change of origin. So, standard deviation, mean deviation, quartile deviation, all these three are not affected by change of origin, correct? So, even if it is increased by 10, my SD, my MD, my QD will not change. That is the reason answer is D. All these three remain unchanged. Understood? Because it is not impacted by change of origin. Plus 10 means change of origin. So these won't change because it is not impacted by change of origin. Now can you tell me the answer for next question then? If all observations are multiplied by 2, which is change of scale, then multiplied by 2, what will happen to the new ST? What will happen to the new SD? I am multiplying all the observations by 2. Multiplication is what? Change of scale. Is SD impacted by change of scale? Yes. Correct. So what will happen? Answer is, because it is impacted by change of scale, my new SD will also be multiplied by. Understand? Exactly with the value I can multiply. All the observations are multiplied by 2. My new SD I can get by multiplying by 2. That is, new SD would be also multiplied by 2. Option A is the answer. Clear? This is what you have to understand. Increase or decrease means plus or minus, which is change of origin, which will have no impact. So all will remain unchanged. Multiplied by 2 divided by 2 means change of scale. It is impacted by the value of change of scale exactly to the extent of this value. So SD will also be multiplied by 2. If it was divided by 5, SD will also be divided by 5 only. Understood? Exactly with the value, the SD will be impacted. Not just SD, even range, even QD, even MD, all have the same property. Here, last one question we will solve. Question number 2. I want each one of you to solve this using the same property, by the way, which is not affected due to change of origin. It is only affected due to value of change of scale. Okay. If Rx and Ry denote the range of x and y respectively, where the relation is given 3x plus 2y plus 10 equals 0. What would be the relation between x and y? You have to give me the answer. Okay. I always told you whenever a question comes on this, always keep y in the left hand side. So 3x plus 2y plus 10 equals 0, which means 2y equals minus 10 minus 3x. Y equals minus 10 by 2 minus 3 by 2x. Can you proceed from this? From here, can you continue? So once you arrive here, y is equal to minus 10 by 2 minus 3 by 2x. Now I told you, ignore the change of origin. Take only change of scale. In that also only value of change of scale. So y is equal to 3 by 2x. In the place of y, I will write range of y is equal to 3 by 2 into range of x. If I cross multiply, it is 2 range of y is equal to 3 into range of x, which is option C. Yes, some of you have already got the answer. Sahana, Tulsi, all you have got the answer, which is R 2 into range of y is equal to 3 into range of x, which is C. C is the right answer. Yes, Tanisha also got. Others understood. Always remember, for measures of dispersion, this is the approach you have to follow. Ignore the change of origin. Pick only change of scale. In that also, ignore the sign. Take only value of change of scale. This is what I have taken. Accordingly, substitute in the place of y, range of y. In the place of x, range of x. That's all. We'll get this answer. Okay. Understood, everyone? Hope everything is clear so far. If you have any doubts, please let me know in the comment box. We can discuss. Otherwise, we can proceed with the next chapter. I'll give you 2 minutes. Quickly go through the entire dispersion chapter. If you have any doubts, you let me know. If everything is clear and we can proceed, please give me a thumbs up so that I can move to the next chapter. Clear, everyone? Guys, send a thumbs up if everything is clear and we can proceed so that I know that you're all on the same page as I am. And it's not just me sitting and revising here, because it's your exams which is coming nearby and you have to, be as attentive as possible and revise quicker than me. So if everything is clear so far, please give me a thumbs up so that I know that you are with me and we can proceed to the next chapter. Quick, quick, quick. Okay, so Avinash is asking, what is the absolute measure of dispersion? Avinash, I just mentioned this. Absolute measure of dispersion is basically all those which are with the units. Okay, we have to write this with the units of measurement, which is nothing but your range, QD, MD, and SD. All these four are absolute measures of dispersion. Okay, relative is their coefficients, which will be written without units, but which are actually used for comparison. This is very important. Just 2 thumbs up. Rest. Are you all there? Listening to the class? Are you with me? ？ . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 .
Yes, ma'am.
。 Quickly, guys, unless you give thumbs up, I can't proceed for the next chapter. We are running out of time. Last 30 minutes. All of us are hungry, right? Quick, quick. We'll quickly wind up another chapter and then we can go for a good lunch. Fine. First, give me a thumbs up if things are clear and we can proceed. Okay, I've got a few thumbs ups now. Others are simply watching. Anyway, I think we have got good numbers. So we can now proceed to the next chapter, which is also another important chapter, which is actually an easy one compared to others because in this you don't have to, put much of what do you say efforts in understanding the question. Okay, because the question is going to be very simple. All you have to do is understand the concept first thing. Second thing, remember the formula. That's all. Okay. So first of all, what do you mean by correlation? Okay, before moving to the chapter, I want you all to first understand what is correlation. The term itself tells you correlation means there is some sort of relationship we are discussing between two variables. So understand this. So far, in all these chapters, what we saw is basically about one variable. Now, if we wanted to calculate arithmetic mean, we used to do x bar. If we want to calculate range of x or standard deviation of x, we were only dealing with one variable at a time. But in this chapter, that is correlation and regression, we always deal with two variables at a time. And that is why there is something known as bivariate data, which means you are collecting and analyzing the data for two variables at a time. That is bivariate data. So whenever in the question paper you see a question where there is both the variables put together, both the variables are coming in the question, like the data is collected and analyzed for two variables together, understand that it is a bivariate data, and that's a hint that the question is from correlation and regression. Because see, your paper is quantitative aptitude, which means all three subjects of math, LR and stats will be jumbled. They won't give you different sections, correct? So everything will be combined. So you have to first analyze and understand which question is from stats. In that also you have to understand which question is from correlation regression. So whenever you see the data is given for both the variables together, which is a bivariate data, which means that the question is coming from this chapter, that is correlation and regression. The hint. Okay. So we only discuss about the bivariate data, which means two data together. Now between these two variables, if we discuss, there is some sort of relationship between the two variables, and that relationship is known as correlation. Okay. The relation can be different types of relation. Let's say if one variable increases, the other variable also increases. Or if one variable decreases, other one also decreases. If both the variables are moving in the same direction, it means it's a positive correlation. Understood? Just because both are coming down, it does not mean it's negative. Both are in the same direction, right? It is still positive correlation. Both are increasing, both are decreasing. It is positive correlation. If one variable is increasing, other variable is decreasing, only then it is negative correlation. Got it? So one variable increasing, one variable decreasing, it is negative correlation. Now, because of increase or decrease in one variable, if the other variable does not change at all, it means there is no correlation. Okay. So this is about positive and negative correlations. Now, next is important aspect, the methods of correlation analysis. Basically, we have to now check what is the correlation, how do you measure, what is the correlation between the two variables. Classic example for two types of, correlation or positive correlation. Example is price and demand. Correct? Sorry, it is not a positive correlation. I'm sorry, it is negative correlation. Why? Because if price increases, the quantity demanded will decrease. If price decreases, quantity demanded will increase. So, which means there is a negative correlation between the two. This is an example for negative correlation. Example for positive correlation. Okay. Now, the most relevant example is that your efforts in the exam and your results out of the exam. So if your efforts in the exam, efforts in the preparation increases, your result also will be increased. Basically, you will get good marks. If the efforts decreases, result also will fall. Okay. So it's a very, very relevant example at this point of time. Efforts increases, results increases. This is a positive correlation. Got it? This is a type of correlation. Next, you have to now measure how much is the correlation between the two variables. And for measuring the correlation, we have different methods. The first method is scatter diagram. The name itself tells you scatter diagram, which means only by way of diagram we analyze. You can see there are different diagrams here. By way of diagrams, we analyze what is the correlation between the two variables. So you can see that if the points are increasing, that means if the points are moving in the upward direction, there is a positive correlation. If the points are moving in the downward direction, that means there is a negative correlation. Okay. Here you can see there is no correlation at all between the two variables. Now, points are moving upward is okay, but this is not a straight line. On the other hand, you can see this is a straight line. If it is a straight line, it's a perfect positive correlation. If it's a downward straight line, it is a perfect negative correlation. Okay. So if it's a perfect positive means upward straight line. If it's a downward straight line, it is perfect negative correlation. So this was about the scatter diagram, which means using diagrams, you are analyzing what type of correlation is there between the two variables. So this diagram will just tell you what is the relationship. Is it positive? Is it perfect positive? Is it negative? Is it perfect negative? But it does not tell you to what extent, what is the extent of correlation between two variables, and which is why we have the next method, which is Carl Pearson's product moment correlation coefficient. So this method will tell you not just what is the correlation, it will also tell you how much is the relationship between the two variables. Basically, it will tell you the degree or the extent of correlation between the variables, which is told by this method. Okay, Carl Pearson's product moment correlation coefficient. Now, this product moment correlation coefficient is denoted by R, okay, which is Rxy, which means the correlation between the two variables x and y. Always remember this R value will range from -1 to +1. Just like your probability will range from 0 to 1, just like that, your R value will go from -1 to +1. Always remember, very, very important question. Now, if the R is 0, which means there is no correlation. If the R goes from 0 to +1, which means there is positive correlation. If the R is going from 0 to -1, it means there is negative correlation. If the R is +1, which means it is perfect positive correlation. If the R is -1, which means it is perfect negative correlation. And that is the reason from perfect negative to perfect positive, your R values will go. It can never go beyond +1. It can never go beyond -1. Always remember this. Got it? So it not just tells you, once you find what is the value of R, let's say it is 0.60 plus 0.60. So this is telling you that there is positive correlation, plus it is telling you this is the extent or degree of correlation between two variables. This is told by this particular method, which is Karl Pearson's product moment correlation coefficient. Now you understood? So this is the reason it is ranging from -1 to +1. Very, very important from theory point of view. This question can be asked. The range from -1 to +1, that is perfect negative to perfect positive. Okay. Now coming to this R value, you can see that, see, generally what happens is, in this case, change of origin, change of scale. Okay. This correlation coefficient, which is R is correlation coefficient. It is neither affected by change of origin nor affected by change of scale. It is only affected by basically sign of change of scale. Now in change of scale, there will be value, there will be sign. It is not affected by value. It is only affected by sign. This sign of change of scale. Understood? So this is, if R xy is given, basically if R xy is given, I can calculate R ub. Always remember, x will become u, y will become v. Okay. So if R xy is given, I can calculate R ub with plus or minus, and that is the reason RUV is equal to plus or minus RXY. Now, plus or minus is given. When do you apply this plus? When do you apply minus? You have to check the change of scale ka sign of both the variables x and y. If the sign of change of scale of both variables are same, then RUV will be equal to RXY. If the sign of change of scale of both variables are different, then RUV will be equal to minus RXY. Just remember, x and y ka sign of change of scale we have to check. If the signs are same for both variables, it will be plus. If the signs of x and y are different, then this will be minus. That's all. Here, we'll solve one example on this. You can see the question here. U is equal to 5 minus 2x. V is equal to 10 plus 3y. Rxy is given, which is 0.65. Calculate what is RUV. Can you try? Quick. U is equal to 5 minus 2x. V is equal to 10 plus 3y. All I want is the sign of change of scale of x. Sign of change of scale of y. So first identify what is change of scale there. Then check what is the sign. Again, in y also identify what is the change of scale. Then check what is the sign. Okay. You can see here, x is getting multiplied by 2, which means 2 is the change of scale. But I want only sign, which is minus. So change of scale of x as minus, negative. Whereas this is the change of scale here, but which has the sign plus. So this will be plus. Now because one is plus, one is minus, we will have to go for this, negative. So RUV will be equal to minus RXY, which is minus 0.5. Very good, Anvita. Anvita has already got the answer. It is minus 0.65. Clear? This is how we calculate. All you have to do is check what is change of scale. Check what is the sign. This is the sign of change of scale of y. Next, check what is the change of scale. Check what is the sign. This is the sign of change of scale of x. If both these are different signs, you have to go for minus. Otherwise, plus. That's all. Clear, guys? I hope you understood this. Okay, we'll proceed now. So this was about R, the property of R basically, which is impacted by only the sign. It is neither impacted by change of origin nor impacted by change of scale. You can see here, R is not affected. R is not affected by change in origin and change in scale. Correct? It is only affected by sign of change of scale. That is, RUV is equal to plus or minus RXY. Now, this plus or minus depends on the sign of change of scale of X and sign of change of scale of Y. Understand carefully. Got it, everyone? So this also we just discussed. The value lies between -1 and +1. Correlation coefficient is unit free, which means this R is what? Unit free. Once you get the value of R, you don't include any unit of measurement in R. Okay, it is always unit free. Next, the formula to calculate R is covariance of x and y divided by SD of x into SD of y. Okay, which is covariance of x comma y by SD of x into SD of y. Covariance का formula will be shortcut formula summation xy divided by n minus x bar into y bar. Okay, and for SD of x we have the shortcut formula root summation x square by n minus x bar whole square. For SD of y we have summation y square by n minus y bar whole square. That's all. Okay, so this is the Carl Pearson's product moment correlation coefficient, which is R. Okay, this is what we have seen so far. Now, just small, theory based question can be asked. You don't have to go behind the logics of this. Just remember, coefficient of determination formula will be R square. Non-determination 1 minus R square. R will be given. Calculate R square, which is coefficient of determination. 1 minus R square will be non-determination. So, another formula for this is R square is explained variance by total variance. This is unexplained variance by total variance. If at all they ask you as a theory question, you have to remember this. Clear? Now, so Carl Pearson's formula already told you that how to calculate not just your correlation, the nature of correlation, whether it is positive or negative. It also told you what is the degree or extent of relationship between the two variables, correct? But let us say that there are some qualitative data. In case of qualitative data, we generally go for Spearman's rank correlation coefficient. So in this, generally the formula is R, the capital R, rank correlation coefficient is equal to 1 minus 6 summation d square divided by n into n square minus 1, where d is nothing but the rank of x minus rank of y, which is basically the difference in the two ranks. Because why is x and y given? Because I told you in correlation regression, always bivariate data. So two data will be given, ranks of x will be given, ranks of y will be given. Take the difference of the two ranks, which is d. Then do d square. Okay, n into n square minus 1. N is nothing but number of pairs. That is how many pairs of data are given. Next, let's say if the ranks are repeated. In some question, the ranks will be repeated. If it is repeated, we'll just do one adjustment. This adjustment formula is summation of t cube minus t divided by 12. Okay. Rest all formula will remain the same. Now, this is about calculating the rank correlation coefficient. Very simple question will be there on this. I hope you have already practiced this question on rank correlation coefficient. So I need not go into the details. I'll just show you one question, how it looks like. See here. So this example you can see sales data is given, advertisement data is given. Okay. Now based on that data, we have to first analyze what is the rank. See, sometimes in the question readily rank will be available, but here rank is not given. So first for sales data, we have to calculate what is the rank. Basically from top to bottom, you go for ranks assigning. Okay. Next, on the advertisement data also go for ranks. So once you have rank for sale, rank for advertisement, now you calculate the difference for the ranks. Then go for D square. That's all is the deal here. 1 minus 6 into summation D square. You have to calculate summation of D square divided by n into n square minus 1. N is nothing but number of pairs. How many pairs of data is there? 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs are given. So it is 8 into 8 square minus 1. That's all. You can see here it is 0.95. 0.95 means it's a plus 0.95, which means it is a positive correlation. And because it is coming near 1 plus 1, it is a high degree positive correlation. So you can see here high positive value is given, which means there is a very good amount of agreement between sales and advertisement. There is a very high correlation between sales and advertisement. This is the interpretation of 0.5. All right. So this was about rank correlation coefficient. Very, very simple formula, very simple concept. You can straight away solve the questions based on the formula. Don't forget the formula because entire question you can go wrong. Now, last method, which is actually the simplest of all methods, which is coefficient of concurrent deviation. Remember that earlier methods, the Carl Pearson's is the best method. The Spearman's is only used for qualitative data, where we generally express them in terms of ranks. For qualitative data, that is the best, Spearman's rank correlation. But if they ask you which is the easiest method, it is coefficient of concurrent deviation. Although the answer you get in this method is not as accurate as the earlier methods. Okay, this is what you have to remember. Now, coefficient of concurrent deviation, the formula is plus or minus root of plus or minus 2c minus m divided by m. Okay, where c is number of pairs of concurrent deviations. Basically, it means that in dx into dy, the difference of x into difference of y, how many plus signs are given? We'll look at one question example. You can understand. M is nothing but n minus 1, which is number of pairs compared. N is equal to number of pairs. M is equal to n minus 1. Okay, this is number of pairs compared. Now you can see here there is plus or minus inside also, plus or minus outside also. How do we do this? Just understand, if this 2c minus m upon m, what value you will get? If that value is positive, which means that the sign we will be using here is also positive, here also positive. Okay, you can see here, if this is positive, we take the positive sign of R. But if this value is negative, can we calculate root of negative value? No, not possible. So we have to convert this negative value into positive value. So we apply negative here. So this will be negative. This will be negative. Here also you have to write negative. So if 2c minus m is negative, we take the negative sign of R. Clear? So always remember, in case of 2c minus m, if this value is positive, which means here also will be positive, this value will also be positive. Now, if the value of 2c minus m itself is negative, This negative I have to convert to positive. So I will write negative here, which will become positive. Here if I am using minus, here also minus. Here if I am using plus, here also plus. Remember this very, very carefully. Understood? So here if this value is negative, I'll use negative here, I'll use negative here. If this value is positive, I'll use positive here, positive here. This is the gist of it. That's all. Clear? I hope everyone understood. Concurrent deviation, we'll see one question. Okay, you can see here, find the coefficient of concurrent deviation from the following data. So first thing what you have to do is, these are the two figures of price and demand. Two variable ka data, I told you bivariate data. Price ka data is given, demand ka data is given. You know there is some sort of relation between the two. Now you have to find what is the relation. What do you do? First thing is, first year you don't compare anything. You can't compare. Second year onwards you compare if this is increased or decreased. 25 to 28 is increased. So right, plus here. 28 to 30 is increased, right? Plus here. It is dropping from 30 to 23, right? Minus. If it is increasing, right? Plus. Like this, go on writing. Similarly, 35 to 34, reducing, minus. 34 to 35, increasing, plus. 35 to 30, reducing, minus. Like this, go on calculating for both the values. This will be d of x, this will be d of y. Then do the product of dx into dy. That is, plus into minus is minus. Plus into plus is plus. Minus into minus is plus. Like this, go on calculating the difference. Now in this difference, dx into dy, the product, you have to check number of concurrent deviation. Basically, you have to check how many plus signs are there in dx into dy. How many plus signs are there? This 1 and 2. So, here m will be 2. Got it? So, you can see here in the formula 2c minus m divided by m. Sorry, c will be, not m. C will be 2, which is concurrent deviation will be 2. M is nothing but number of pairs compared, which is n minus 1. N means how many data are given? 1, 2, 3, 4, 5, 6, 7, 8. 8 data is given for n. M will be 1 less than n, which is 8 minus 1, which is 7. Got it? So M will be 7, C will be 2. Straight away substitute in the formula. That's all. C. 2c minus m divided by m. We have calculated. We are getting minus here. Correct? Minus 3 by 7. Because you are getting minus here, this will also be minus itself. This will also be minus itself. That's why we have the answer minus 0.65. Clear? I hope everyone got this. It's written here. Because it is minus, we take negative sign both inside and outside of the sign. Inside also we take negative, outside also we take negative. Clear, guys? This is about the last method of correlation. Okay. So far we saw what do you mean by correlation, which means it's the relationship between the two variables. Always two variables we will collect and analyze because this is the bivariate data, which means for two variables data we will simultaneously collect and analyze. Okay. So in that there are two types of correlation. One is positive correlation, one is negative correlation. If both the variables are decreasing or increasing, we will call it positive. If one is increasing, other is decreasing, we call it negative. Okay. Then we have different methods for calculating the correlation. First method is scatter diagram. We're using form of the diagrams. We'll only check what is the correlation between the variables. Next is Karl-Pearson product moment. Third one is Spearman's rank correlation, which is used for qualitative data only. And lastly is the easiest method of all, yet the answer won't be as accurate as the earlier methods, which is coefficient of concurrent deviation. So far, we have completed the concept of correlation. Okay. So in this, if you have any doubts, anything needs to be explained, please let me know. We have 5 minutes. Okay. If this is clear to everyone, please let me know in the comments. Can proceed with the next chapter, which is regression, in the evening session. Okay. We can wind up the class. So please let me know in the comments if you are okay. Everything is clear. The concepts are clear. Please put a thumbs up or say it is clear. If it is not, if you have any doubts, please ask so that we can straight away move to regression in the coming session. Okay, guys, quickly give me a thumbs up so that we all can go have some good lunch, come back with more energy in the evening session so that we can complete the next topic of regression as well. Ma'am, can I get this chart? Yes, Anna, definitely circulate the chart soon after the session, which will be circulated with all of you. You can utilize the chart to, revise the formulas for the coming days. Every day, revise it. It will be easy for you during the exams. Yes, thank you so much. Okay, I'm getting some thumbs ups. Please let me know if there's any doubt so that we can clarify. In the coming session, we can straight away start with regression. So evening session, I want all of you with more josh. Okay, so have some good lunch, but keep it very light so that you don't end up sleeping in the afternoon. Nap is okay, but sleeping is not because exams are nearing. So you need to keep your food really light. Okay. So yes, guys, thank you so much for a wonderful session. It was good interacting with you all. I hope the concepts were clear. So any doubts, you can let me know after the class as well. So have a good lunch. We'll see you in the evening session. Thank you.